Greetings. Here we have a good question from Signals and Systems. You see, consider a discrete time linear time invariant system or linear shift invariant system, we could say, whose input x of n and output y of n are related by this one. Now the question is the system causal? Okay, let's work on this. Just give me 2 seconds. Okay, see, let's take a beautiful system. Okay, the beautiful linear time invariant system, and now we have input x of n and output as say y of n. Okay, so we know that a linear time invariant system will be characterized by unit sample response or impulse response. Okay, that is say h of n. So the beauty again is that LTI system we can also say as a signal. No other system we can give this title, but for LTI system we can also say as a signal, because we are showing h of n as a system, but this h of n itself is a signal or a sequence in discrete sense. Anyways, you see, now you have linear time invariant system, and we know that this linear time invariant system is causal if its impulse response or unit sample response is 0 for n less than 0. Okay, so if h of n satisfies this condition, then yes, we could say this LTI system is causal. And to define this, to show this, we have a question this way. Okay, now we have to check whether or not this system is causal. See, causal, Miss LTI system, this causal, she doesn't belong to Tollywood causal. She is not again Bollywood causal. This causal belongs to Signals and Systems. Okay, so you see, anyways, we need to find, first of all, we need to find h of n. Okay, whenever you have LTI system, take its h of n to test its causality. That's it, very simple. So we will take h of n. See, I have a linear time invariant system. When I give input as impulse input, I would get response as impulse response. So let me take operator t. So let me transform input delta of n to output h of n. Okay, so we will take now, in this case we will take input as delta and we will take output as h of n. Okay, so therefore I will take like this: the impulse response of the system h of n, impulse response of the system h of n is equal to k is running from negative infinity to positive n. I'm using this one. Okay, see, whenever I take x of n as delta of n, then y of n becomes like h of n. Okay, so I'm using this with this. Alright, so therefore you have 2 to the power of k minus n. Now instead of taking x of k plus 1, now you take delta of k plus 1. Alright, so you have this. Now what you do, just use the properties of impulse function. So now what you have, h of n is equal to, so h of n, so k is negative infinity to positive n. Let me take another color, let me use now red. Now this becomes what? So this becomes 2 to the power of, now k, I'll take k as negative 1 minus n multiplied by delta of k plus 1. So the property yields this result. Okay, so what did I use now? See, you know very well, right? So see, for example, if you have something like x of k, okay, x of k multiplied by say delta of k minus l is equal to what? This is nothing but x of l delta of k minus l. So the same thing we used here. Assume x of k is 2 to the power of k minus n. This is like x of k. Okay, and now what you have here, delta of k plus 1. It's nothing but this is delta of k minus of minus 1. Now just multiply these two. Now x of k delta k minus L, where L is equal to what here? Negative 1. This becomes what now? X of L. So x of L, that is in place of L, what do you have now? This is nothing but, I'm writing here, see, this is L is equal to what do you have? Negative 1. So x of minus 1 delta of k minus of minus 1. Okay, now x of k is equal to 2 to the power of k minus n. Now in place of k, you put in place of k this negative 1. So we get like this 2 power minus 1 minus n multiplied by delta of this k plus 1. Okay, so let me rewrite this one again in the new page. So just give me 2 more seconds. Meanwhile, I'll take this new page. Okay, I am ready with my new page. So let us revisit our equation. Okay, so impulse response h of n is, after using the property k is equal to minus infinite to n. So we have 2 power minus 1 minus n multiplied by delta of k plus 1. Okay, anyways, this is simple. So k is running from negative infinity to n. So this is to take this negative sign as common, minus this is 1 plus n multiplied by delta of k plus 1. So now what do? Now let me, before I do something, let me take this red marker again. So let me assume like this. Let k plus 1 is equal to L. Let me take k plus 1 is equal to L. So I remodify this equation as follows. H of n. So h of n is equal to, so I want to change the limits for k to L. So now L is equal to what I get now. So L is equal to, I get minus infinite to n plus 1 minus infinite to 1 plus n delta L. So this is 2 power minus 1 plus n. Do you agree with this? Yeah, see, for example, now in the lower limit we have k is equal to negative infinity. So you plug in this k is equal to here. So L is equal to minus infinity plus 1 is again minus infinity, and in the upper limit we have n. This is k is equal to n again. So you plug in k is equal to n. So we get L is equal to n plus 1. So the new limits for L is minus infinite to n plus 1. Okay, so minus infinite to n plus 1, k plus 1 equal to L. So delta of L, and this is again as it is. Okay, there is no k term here, so therefore it is as it is. So the limits are with respect to L, and you have no L component here. So what to do now? Happily we can bring this quantity outside this summation. Okay, so let me use again, just give me 2 more seconds. Meanwhile, let me collect my black marker. So now h of n, so let us bring this quantity outside. You have 2, L is negative infinity to n plus 1 delta of L. Okay, now now again, what is this? So this quantity is what? So this quantity is u of n plus 1. Simple, right? So h of n is 2 power minus 1 plus n multiplied by, this is u of n plus 1. I'll just tell you how do we get this u of n plus 1 out of this, but for now just accept u of n plus 1, and I'll just tell you in some 20 to 30 seconds from now. Okay, see, now anyways, if you observe carefully, see, present output at this instant n depends upon the future quantity, anyways it is non-causal. Otherwise, in literature, just don't check it this way. In the literature, go like this. See, now if you have linear time invariant system, so whenever you have linear time invariant system, h of, as we know very well, if h of n equal to 0 for n less than 0, then this system is causal. Yeah, if h of n equal to 0 for n less than 0, system is causal. Now we will check whether this condition satisfied or not in this case. Now straight away, if I take h of 0, if n equal to 0, there is no significance of this, okay? So if n equal to 0, now I get 2 power minus 1 multiplied by u of 1. U of 1 equal to what? 1, you see? If I take h of 0, so we get 2 power minus 1 multiplied by u of 1, and u of 1 is equal to 1. So u of 1 is equal to 1, not equal to 0. So this is okay, because h of n equal to 0 for n less than 0. That means for equal to 0 and greater than or equal to 0, h of n need not be equal to 0. So we have to satisfy this one. So therefore we will take any value for n less than 0. Let me take n is equal to negative 1. If n is equal to negative 1, so you have 2 power minus 1, n is equal to negative 1. This is gone. U of minus 1 plus 1. Okay. So what is u of minus 1 plus 1? U of minus 1 plus 1 is u of 0, and u of 0 is equal to 1. Okay, see. Now h of minus 1 is 2 power 0, 1. This is u of 0. So u of 0. What is u of 0? U of 0 is also equal to 1, which is not equal to 0. You see, h of n must be equal to 0 for n less than 0. Now we took a value for n less than 0, that is negative 1. H of minus 1 we are expecting as 0, but we got not equal to 0. So therefore the given system is non-causal. Okay, that's fine. See, you take your step function and discrete domain. If it is my u of n, so you have, see, like this. So I have my step function, so on, okay, starting from 0, 1, 2, 3, so on, and for negative n, negative 1, negative 2, negative 3, so on, u of n equal to 0. So see, u of 0, this is my u of 0 component. So u of 0 is equal to what we have? 1. So u of 0 is equal to 1, which is not equal to 0. Okay, so we are expecting h of n to be 0 for n less than 0, but we got this one. Okay, so therefore system is non-causal. So the answer to this is system is non-causal. Okay, this is straightforward. So therefore the system is not causal. Now we will see how we get u of n plus 1 from this. Okay, so see, what we have is this. What we took, let me take, you have summation. Let me rewrite this again. L is negative infinity to n plus 1 delta of L, and we wrote this one as u of n plus 1. But how? Is it difficult here? There is no big deal in this. Let's investigate now. It will take no time. You see, we know very well that any signal, any arbitrary signal convolved with impulse quantity, impulse signal, is always the same signal. Okay, so x of n convolved delta n is x of n again. Now what we will do is this. Now see, if I take x of n convolved with u of n, then what we get? You see, I'll just take its form. So k is running from negative to positive infinite. So we have x of k, u of n minus k. Yeah, this fact we are well familiar with. Now you have a shortcut here. You need not graph it again, just a shortcut, use it. See, you know what, step function will always sacrifice for limits, always. Yeah, so therefore this step function, because of this step function, now limits are going to change. Now shortcut is this here. If you are really eager for tricks, now just make n minus k equal to 0. Okay, if n minus k is equal to 0, what is k? K is equal to n. Why are we going to find this k? Because the limits are running for the values of k. Okay, so anyways, n is this positive here, so therefore this becomes what? Don't hamper this. K is negative infinity. This upper limit now becomes n. Okay, so therefore x of k. Again, don't take this u of n minus k. This fellow always sacrifice for limits and he will be out of race. So therefore it is this. Alright, so this is what x of n convolved with u of n. In the left hand side you can put x of n convolved with u of n. Now from this, what do we know? Any arbitrary signal or any arbitrary sequence convolved with delta of n is again that arbitrary sequence. So now this anything, I'll take it as you see. Now this anything is this. So how do we write now? Let me write like this. Okay, this is anyways, let me make it simple. This is anyways u of n convolved with x of n. Okay, now this x of n, I'll take it as now delta of n. Okay, so u of n convolved with delta of n is equal to what? K is running from negative infinity to n. Now if it is x of n, this must be x of k. If it is delta of n, this must be delta of k. Now any function or any signal or any sequence, in this case in discrete domain we should say sequence, any sequence convolved with delta of n is again the same sequence. So therefore this left hand side quantity is nothing but u of n. Okay, so finally what do you have? So finally we have like this, u of n is equal to k minus infinite to n delta of k. That's it. Okay, now if you want to find for u of n plus 1, now what you do? Just plug in n plus 1 in the upper limit. So this n becomes now n plus 1. If it is n, this is n plus 1, n plus 1. Sometimes life is simple like this. Okay, if not always. Okay, so therefore what do we have here? Just compare these two. Now just compare these two. L is equal to negative infinity to n plus 1 delta of L. K is equal to negative infinity to n plus 1 delta of K. So both are equal to same u of n plus 1. So therefore this form is u of n plus 1. Now h of n is equal to this. Now anyways, for LTI system h of n is equal to 0 for n less than 0. But unfortunately we took n as negative 1 and we were expecting to be 0, but we got non-zero value, that is 1. So therefore the given system, this fellow is not causal. Again, causal belongs to signals and systems. Okay, not Hollywood or Bollywood causal. Okay, anyways, you see causal means what? Cause and effect, because all practical systems are causal systems. See, practical systems means what? Output we get always because of input. Okay, that means effect is because of cause. Input is cause, output is effect. So all practical systems obey this. So therefore all practical systems are causal systems. So all practical systems are causal systems. This is very, very important to understand at this juncture. And And again, see, even your oscillator, we often think that oscillator produce output without input being applied, but is it correct here? Literally, just go home and think on it. Don't think, just ponder over. Is oscillator producing output without input being applied? Even oscillator also taking input. Okay? Thank you. Just think on it. So I'm interviewing again. Thanks and bye.